Hi everyone and welcome on board your really long-haul flight. On this channel we've put together a compilation of some of the most jaw-dropping moments from the sky. So now all that you need to do is find a comfortable place to sit, bring out your favorite drink, sit back and relax. Was it a technological marvel that nearly succeeded or simply a product of espionage? There are a lot of questions and misunderstandings about the Tupolev TU-144 or Concordski as many of you might know it, but perhaps the thing it is most remembered for was a tragic fatal crash that happened at the 1973 Paris Air Show almost exactly 50 years ago. Stay tuned. The allure of supersonic passenger travel wasn't unique to the makers of the Concorde. I just did a video about the mysterious Everglades jetport and how it was deeply connected to the American efforts to create their own supersonic airliner. But what about the Soviet Union? In the early 1960s, the Soviets also had a very busy aviation industry that had created a number of attention-grabbing aircraft, both civilian and military. And since it was public knowledge that the British and the French were working on a supersonic passenger aircraft, the Soviets weren't just going to be sitting on their hands. Now, you might think it's a little bit weird that the Soviet Union would even be interested in a design like that, something that would carry relatively few passengers over just medium distances. But the Soviets knew the propaganda value of launching such a design, especially if they could do it before the West, and they weren't just about to throw in the towel. The Soviet Union launched the Tupolev TU-144 program in July 1963, just 6 months after the launch of the Concorde program. And after a surprisingly fast development, even by the standards of that era, the aircraft flew for the first time on the 31st of December 1968, about 2 months before the Concorde did. But from the very start, there were suggestions that the Tupolev TU-144 managed to beat the Concorde to the air simply because of either espionage or because its development was really rushed, resulting in an aircraft too immature to be really useful. With that criticism in mind, let's look at what the Tupolev TU-144 specifications actually were and how they compared to the Concordes. To start with, the Tupolev TU-144 was a bit bigger than the Concorde. It was around 4 meters or 13 feet longer and with a wingspan just over 3 meters or 10 feet greater than the Concorde. As a result, Concorde had a single-aisle cabin layout with 2 seats on either side of the aisle in what was essentially an all-business cabin. This gave the Concorde a capacity of 100 seats, although in theory it could probably squeeze in a few more if needed. But by contrast, the Soviet jet actually had a 2-class cabin with 5 seats on each row in second class and 3 seats across in the first class. This meant that in total it had seats for 150 passengers, making its passenger capacity 50% higher than the Concorde. The TU-144 was actually also a little bit faster. You see, Concorde's designers had picked a cruise speed of Mach 2, specifically to be able to use aluminium throughout, which was a much better understood material and easier to work with compared to the more exotic titanium which the Soviets favored. What this meant was that in practice Concorde's speed was temperature limited to Mach 2.04, although it could fly a little bit faster in the right conditions. The Tupolev TU-144 instead used titanium and steel for its wing leading edges and also in some other areas where they were subjected to higher friction heat in cruise, and this enabled it to cruise at Mach 2.15, but in practice it cruised at Mach 2 just like the Concorde. Having looked at all of that, you could say that the Tupolev TU-144 was actually a bit more ambitious than the Concorde, but not quite as extreme as Boeing's plans for the 2707 SST. Like I mentioned in my last video, in their most conservative plans, the American SST was supposed to fly at Mach 2.7 using a wide-body construction carrying 230 passengers, but as we all know, that never happened. But now we get to the range, and this is where the specs of the Tupolev TU-144 actually starts to fall behind those of the Concorde. Even in its final D version, which actually never got to carry passengers, the Tupolev 144 couldn't fly further than 3,500 nautical miles, and that's to be compared with the Concorde's 3,900 nautical miles. Now, that might not sound like a huge difference, but it meant that the Concorde could fly across the Atlantic while the Tupolev 144 just couldn't. But was this really a deal breaker for the design? Actually, no. And that's because the Soviets were planning to use the aircraft a bit differently from the way the British and the French were. And that strategy difference could have easily tipped the balance into the Soviet jet's favor. A key factor that could have helped the Tupolev 144 to become successful was simply geography. Unlike Britain and France, or many other countries with early orders for the Concorde, the Soviet Union was huge, and this meant that the use case for the Tupolev 144 was radically different than the Concorde's. Simply put, the Soviet Union was so big that a supersonic airliner would be quite handy for domestic trips. But then you might ask, doesn't that mean that the Soviet jet would have to fly at supersonic speeds over land? Well, this was a big no-no for the Concorde, and those who were passengers on ships and heard it crossing the sound barrier over them will tell you why that was. Now, it turns out the Soviets weren't as worried about Mach busting some small towns. When it was in service with Aeroflot, the airline primarily flew it over sparsely populated areas, but beyond that, they didn't really have any limitations. And when it came to international travel, the Tupolev 144 would eventually have been able to fly from the eastern reaches of the Soviet Union to destinations in Asia by going supersonic over water. Another difference between the Soviet Union and the West, which would come into play a little bit later, was of course the fuel prices. Because even after the Yom Kippur War in 1973 and its effect on fuel prices worldwide, the Soviet Union wasn't as affected as the rest of the world because of its domestic oil production. And this meant that a lot of the factors that would spell real trouble for supersonic jets in the rest of the world could be more manageable for the Soviets, at least in certain extent. So to recap, the Tupolev 144 actually had a solid use case that would have allowed both Aeroflot and its manufacturers to gain experience in passenger supersonic flights. This could have possibly given them the opportunity to slowly improve its range and capacity over time. So what happened? Well, to try to understand this, we have to look a little bit closer at the aircraft's actual design. Other than the size difference, the Tupolev 144 and the Concorde look really similar, but there are some big differences. Obviously, they both use a delta wing, which isn't actually that surprising, because most designers of supersonic jet projects turn to delta wings to meet the radically different lift and drag requirements between a supersonic cruise at Mach 2 and the much lower subsonic aerodynamics used during takeoff and landing. Concorde was equipped with what's called an OG-shaped or S-shaped delta, which made it behave well in a range of different center of gravity configurations and also provided a relatively low landing speed at a high angle of attack. But by contrast, the Tupolev 144's wing design was much simpler. This meant that it needed canards, that's those smaller wings on its nose, to improve its low speed characteristics and to reduce its takeoff and landing speeds. The first prototype, by the way, didn't have those canards. That really first only appeared on the production variant of the jet. But the canards also added weight, and to keep them from producing drag in cruise, Tupolev designed them to be retractable, which added even more weight. And even with the canards extended, the Tupolev still needed to land at a higher speed than the Concorde did, requiring longer landing distances, more durable tires, and a brake parachute. The other key to why the Tupolev 144 didn't have the range of the Concorde had to do with its engines. In theory, the first engine the Soviets fitted to the 144 was actually more advanced than the Concorde's. This was a low bypass afterburning turbofan called the Khrushchev NK-144. By contrast, the Concorde had the Rolls-Royce Snecma Olympus 593 turbojet, which was a rather mature design, basically an evolution of the engine for the Avro Vulcan bomber, which first flew already back in 1952. Obviously, the Concorde version was substantially improved, but more importantly, this engine was a much better choice than the theoretically more modern turbofan of the Tupolev 144. But how does that make any sense? All airliners today have turbofans, not turbojets, right? Well, yes they do, and that's because, as I've explained in other videos, it's normally more efficient to push a larger amount of air backwards at the same speed than to push the same amount of air backwards at higher speed. That's why turbofans today are getting bigger and bigger in diameter, with more and more air bypassing the turbine itself, which is known as a bigger bypass ratio. But this assumes that we're flying subsonic, like today's airliners do. At supersonic speeds, this larger frontal area of high bypass turbofans can actually start to become a problem, adding much more drag. Now, obviously I'm oversimplifying this a little bit. There are many supersonic military jets today with afterburning low bypass turbofans, but at the time that this was happening, getting those type of engines to work efficiently was really hard. All this meant that Tupolev would eventually also adopt a turbojet engine for the 144 called the Kolesov RD-36-51. But this came much later. All Tupolev 144 passengers flew on the original, less efficient turbofan version. And actually, it's not just the engines themselves that ended up hurting the 144's efficiency and range. There was also another issue with these engines, which had to do with where they were placed. As you can see here, the 4 engines on the Tupolev 144 are much closer to the aircraft's centerline than the Concordes are. Now, we pilots like having the engines close to the plane's centerline because that means that we don't have to worry as much about asymmetric thrust if one engine were to fail. But it seems like the main reason why the Tupolev engineers put the engines where they did was because they wanted, or rather needed, the engine air intakes to be very long. I will eventually do a video focusing more on Concorde itself, where I'm going to go into this in more detail, but what you need to understand here is that the Concorde's engine intakes were key to its success. Concorde was the first airliner to have an analog fly-by-wire control system, but it also had an inlet by wire. And why was that? Well, if you think for a minute about how much air a jet engine actually needs to operate properly. During takeoff and at low speeds, it really needs all of the air that it can get. But as soon as the aircraft speed starts coming close to the speed of sound, designers needed to make sure that the air going into the engine was not supersonic. Obviously, on normal airliners this isn't really a problem because we don't go supersonic. Fighter jets and other supersonic jets have their own ways of dealing with this problem, but in practice, really fast and big supersonic jets needs engine inlets that can change their geometry at different speed regimes to make sure that their engines can continue to function properly. Both the Concorde and the Tupolev 144 had variable geometry inlets. The inlet by wire system in the Concorde controlled the inlets and various gates at different speeds and conditions, including after an engine failure at high speed. And crucially, they also help make the engines more efficient in cruise by increasing the overall pressure ratio. But the inlets on the Tupolev 144 were much simpler. So to help control the airflow and keep it more consistent, the Soviet engineers made the inlets really long, twice as long as on the Concorde. But this additional length also added a lot of drag. What all of these issues actually meant was that to sustain the necessary power in cruise, the Tupolev 144 needed a little bit of afterburner continuously. An afterburner works, simply put, by dumping extra fuel into the back of the engine nozzle and then burning it. This generates more thrust, but at the price of a much higher fuel burn and noise. And speaking of exhaust nozzles, the ones on the Concorde also had a variable geometry, which not only made it more efficient, but it enabled reverse thrust on landing, which was another thing missing from the Tupolev. That's partially why it needed those drag parachutes after landing. The lack of reverses might also have been why the Tupolev 144 had a unique 8-wheel main gear bogie setup, possibly to allow for better braking. Although that gear design might also have to do with the way it retracted into the fuselage, requiring relatively small diameter wheels and tires. But according to some analysts, the main problem with the Tupolev 144 was just the rush of its initial development. It seems that completing it and getting it into the air before Concorde was a highly politically charged decision. And this takes us to that fateful Paris Air Show on the 3rd of June 1973, 50 years ago. Both the Concorde and the Tupolev TU-144 were scheduled to perform back-to-back shows, meaning that effectively the show became a contest between the two. Unlike Concorde, the Tupolev didn't have a fly-by-wire system, but it had a simpler stability and control augmentation system. For the airshow, it appears that some protections and limitations in this system were turned off, possibly to allow for more elaborate and eye-catching maneuvers. The Tupolev pilots had performed their airshow once already the day before without any type of issues, but on the 3rd of June, just after the Concorde's performance, the Tupolev TU-144 crew appeared to make an unscheduled steep climb near the end of their routine, which had not been part of their show the previous day. This was then followed by a very steep dive, and it appears that the airframe of the TU-144 became overstressed when its pilots tried to pull out of the dive, causing it to completely break apart. The aircraft hit the ground, instantly killing all 6 crew members on board and causing 8 more fatalities on the ground. The investigation into the crash didn't end up reaching a definitive conclusion as to what caused it, and this gave rise to several conspiracy theories. Some claimed that a French fighter jet was flying too close to the TU-144 in order to photograph its canards, surprising the Soviet pilots and leading to that final maneuver. In the Soviet Union, some would later claim that the British and French deliberately let Soviet spies steal compromised Concorde files to lead engineers into making a faulty aircraft, which actually sounds insulting both the Western and Soviet engineers, to be honest. There were also theories around construction methods, metal fatigue, or issues involving the bypassing of the stability system. But in any case, Tupolev, after the crash, ended up strengthening the structure and modifying the flight controls to make overstressing the aircraft much more difficult. When it came to actually making the aircraft useful, both the Concorde and the Tupolev took a very long time to enter into service. And when they actually did, the Tupolev again beat Concorde by 1 month. Well, sort of. In reality, when the Tupolev TU-144 entered service in December of 1975, it only flew mail and cargo, basically continuing its test program. It actually started flying passengers in November of 1977, well after the Concorde did. As for what it was like to fly in, apparently its pilots were kept really busy because the design was still in its infancy and reliability always remained a problem. But probably the best known problem it had, at least from a passenger perspective, was its cabin noise, which was so bad that people famously had to pass handwritten notes to each other in the cabin in order to communicate in flight. This had partly to do with the continuous use of afterburner in cruise, something the Concorde only needed during takeoff, but also with the position of the engines and a very noisy cabin pressurization system. In the end, the Tupolev TU-144 would stop flying passengers after just 7 months or 55 flights. This happened after a second accident, a crash landing that took place in May of 1978 during a delivery test flight of the improved Tupolev TU-144D variant. After an undetected fuel leak, the aircraft caught fire and 2 flight engineers perished in the crash while 6 others on board survived. Even though the cause of the crash only affected this new variant, it appears that by this point the Soviet leadership and Aeroflot had simply had enough. The Tupolev TU-144 never flew passengers again, even though some freight and mail flights restarted eventually. Later on, another incident included an uncontained compressor disc failure in August of 1980, which happened during cruise at supersonic speed. Another aircraft also suffered some minor structural issues, so in total the Tupolev TU-144 fleet made just 103 revenue flights, including cargo. But plans to bring it back to service did persist. We know that because its production officially didn't end until 1982, and after that it only got some use as a testbed, including for pilots of the Soviet Buran space shuttle. There were other plans for more versions of the aircraft, including military ones, but the Soviet Air Force and Navy just weren't that interested. And more recently, there were actually thoughts to revive the program or launch its successor called the Tupolev TU-144. That version would use hydrogen-burning engines and some technology borrowed from the Tupolev 160 bomber, but it also didn't go anywhere. And in a really odd twist, especially given the current geopolitics, the last user of the Tupolev TU-144 actually was NASA.
A new period of cooperation in aeronautics between Russia and the United States.
This was part of a program that NASA called the High-Speed Civil Transport. In that program, the last Tupolev 144 ever made was refurbished and fitted with new afterburning turbofans borrowed from the Tupolev 160. The plane was flown within Russia from 1996 until 1999, when NASA ended the program. Today, a number of Tupolev 144s are showcased in various museums, just like the Concordes are. So, was this aircraft just another failed supersonic project, or even the product of espionage? Well, sadly, it seems like this interesting plane was seen by those in power mainly as a propaganda tool, which no longer really mattered after its initial successes and failures. As for the espionage question, ultimately it didn't really matter. In the end, it was the execution of the project and the poor support that killed it, rather than anything to do with its origins. Its wings were longer than those of a Boeing 747, and even the Antonov 225, it cost a literal fortune to build, but it only flew once for less than 30 seconds. So, what was the Spruce Goose, and why was it made in the first place? Today I will tell you a story about a true aviation icon, which started off as an incredibly ambitious wartime project driven by one man's passion, and got to fly only because that passion turned into an obsession. Stay tuned. It's really difficult to get a sense of the size of this aircraft by just looking at a picture of it, but you can start to get a feeling for it if you look closer at those 8 engines on its wings. They don't look very big, do they? But these are Pratt & Whitney R4360 Wasp Majors. They each have 28 cylinders arranged in 4 rows and are the biggest radial engines ever made. As you can see, they look much bigger on a Boeing 377 or a Convair B-36. But we're getting a little bit ahead of ourselves here. To understand the Spruce Goose or the Hughes H-4 Hercules, which is its proper name, we need to dig deeper into what aviation looked like before the start of the Second World War, and more specifically, we need to look at flying boats. These are aircraft with sea hulls, who, as the name suggests, were built to operate from the sea or other bodies of water instead of from airports. Now, have you ever wondered why we pilots wear the uniforms that we have, or why passengers generally board the aircraft from the left-hand side? Well, both of these details have a naval connection. The boarding is done from the left because large ships were already boarding passengers from their left or their port side. There were a lot of direct links between passenger ships and passenger aircraft in those early days of aviation, and for good reason. In the 1930s, Pan American World Airways, or Pan Am, started using its Clipper flying boats for its multi-leg long-haul trips that spanned the world. And these flying boats used the same ports and piers as passenger ships did, so Pan Am decided to dress its pilots in more or less the same uniforms as ship crews used. Until then, pilots were usually wearing leather jackets and silk scarves instead, which made sense because many of those early aircraft had open cockpits, where it could be a bit drafty, to say the least. Back then, airfields were still rare or non-existent in many parts of the world, so by relying on normal seafaring ports, Pan Am and other early airlines didn't need to worry about finding suitable airports or other special infrastructure for those long trips. Now, all of this would eventually change, but the point that I want to make here is that when World War II broke out, many flying boats were still in service with various airlines around the world. And the fact that flying boats didn't need anything more substantial than a decent pier instead of an airport was also a handy advantage for many military planners, which brings us to something called the Battle of the Atlantic. For much of the Second World War, Britain and the Soviet Union relied on supplies that arrived primarily from the United States and Canada on commercial shipping. And at the same time, German and Italian U-boats were trying to sink as many of those ships as they could to disrupt the Allied war effort. This battle lasted more or less for the entirety of World War II, and it was constantly evolving. Commercial ships initially crossed the Atlantic alone, then in convoys, but German strategists believed that they could sink more ships faster than the Allies could actually build new ones. Now, this battle is too complicated for me to analyze in detail here, but the point is that the Germans were constantly getting better and better at it. After the war, Winston Churchill wrote, "The only thing that really frightened me during the war was the U-boat peril." So how do you solve this problem? How do you ship goods and people over an ocean infested with hostile submarines? Well, a number of different strategies were tried, but by 1942 the situation had gotten so bad that someone thought, how about using flying boats? Now, at the start of the war, many airliners, including flying boats, had already been repurposed for military use, but even the largest of these aircraft, like the Boeing 314 Clipper, weren't really big enough to make an impact as a cargo aircraft. Something much bigger would therefore be needed. Something that could carry at least 2 Sherman tanks, each weighing around 30 tons or around 700 soldiers. But the other problem was that this aircraft couldn't compete for resources with other military aircraft like fighters and bombers. And that meant that this new transport aircraft would not only need to be huge and have a boat hull, it would also have to be made using a non-war critical material like wood. Of course, back then aircraft with wooden structures weren't unheard of, and they even included military examples like the de Havilland Mosquito, but making a large freighter almost completely out of wood will be a huge challenge to do. The person who initially came up with this idea for a large freighter plane was a shipbuilder called Henry J. Kaiser. His shipyards were one of the many places building Liberty ships, which I'll get back to shortly. Kaiser referred to his flying boat freighter idea as the flying cargo ship, but he knew nothing about building aircraft, so he turned to another wealthy businessman, Howard Hughes. And this is where the Spruce Goose really starts to take shape. But why was only one ever built, and how did it actually come to survive to this day? Which it actually did. Well, right from the start, this project was hit by a lot of uncertainty and frustration. Howard Hughes was quite a complicated and busy man, to put it very mildly. Depending on who you were at the time, you would have heard of him as a Hollywood film producer, an airline owner, a businessman, an aircraft manufacturing executive, or even as a pilot. Hughes' wealth came primarily from the Hughes Tool Company, which his father had founded, making equipment and holding key patents for tooling for the oil industry. But back in 1939, Hughes also got into the airline industry by getting control of Transcontinental and Western Airlines, probably better known as TWA. In that role, Hughes was instrumental in the development and funding for Lockheed's Constellation, which I've already talked about in a previous video actually. But even before that though, Hughes had already founded the Hughes Aircraft Company, designing a number of aircraft for civil and military use, none of which actually ultimately went into production. Even so, the Hughes Aircraft Company was very busy during the war, making components for aircraft and other wartime equipment as a subcontractor, while still continuing to pursue their own aircraft designs. So that was the situation when Henry Kaiser approached Howard Hughes in 1942 to discuss his idea of a flying cargo ship that could overfly the U-boat infested waters of the Atlantic rather than sail through them. And Hughes immediately jumped on the idea. By this time, the Hughes Aircraft Company had been exploring the use of wood laminates in aircraft construction, making them super thin, very light but still quite strong. This process was called Duramold, and it would turn out to be a mixed blessing, but I'll get back to that. Originally, the aircraft was going to be named the HK-1 for Hughes Kaiser 1 as the first joint project by the two men. 7 different design configurations were considered, including one with a twin boom fuselage that Hughes had used in other previous concepts, but the configuration that was eventually chosen turned out to be a little bit more conventional. The Spruce Goose was a high wing design, like most flying boats at the time, with a cantilever wing and the entire structure made out of Duramold wood laminate, except for some control surfaces that were fabric-covered aluminium. The plane was 66.6 meters or 218 feet long, and its wingspan measured 97.5 meters or 320 feet. In other words, its wingspan was about the same as the length of a modern football field, meaning that the only aircraft with a bigger wingspan in the history is another one-off design, the scaled composite 351 Stratolaunch Rock, which flew for the first time in 2019. But building the Spruce Goose wasn't easy. Delays in the program eventually caused the partnership between Henry Kaiser and Howard Hughes to break up completely. Like I said earlier, at the time this was going on, Kaiser was building Liberty ships, and to understand why he left this project, you have to know a little bit more about those ships. Because of the staggering U-boat losses, Liberty ships were designed for quick manufacturing. Over 2,700 of them were eventually built, and crucially, by 1943, building one took an average of just 39 days, from laying the keel to the finished ship sailing away under its own steam. Contrasting that incredible pace with the way that Howard Hughes went about designing and building the HK-1 was, well, a bit awkward, I guess. The initial contract that Hughes and Kaiser had was for 3 HK-1s, and all 3 should have been delivered 2 years after the contract was signed on the 16th of November 1942. But that just wasn't going to happen. Just a year and 4 months after the contract was signed, Henry Kaiser left the partnership. Hughes decided to continue the project alone, and the aircraft was therefore renamed from HK-1 to H-4 Hercules. Hughes also renegotiated the contract for the project, limiting it to just 1 aircraft, basically as a development study. Now, most references suggest that Kaiser left the project because he was getting increasingly frustrated with Hughes, whose obsession with every single detail of the aircraft was slowing things down dramatically. But was this actually true? There is plenty of evidence that Howard Hughes had OCD, which was a key part of his eccentricity, and to be fair, we are talking about what would become the biggest aircraft ever made, being developed by a relatively small manufacturer. So knowing that, delays wouldn't have been surprising, even without a perfectionist calling the shots. But Kaiser may have had much more pragmatic reasons for abandoning this dream of a flying cargo ship. You see, Kaiser took that decision around March 1944, and that date is important because by then the Battle of the Atlantic, which was the whole point of developing the flying cargo ship in the first place, had changed dramatically. Already by the second half of 1943, developments in code breaking, radar, radio direction finding equipment and anti-submarine weaponry meant that German U-boats weren't nearly as effective against ship convoys as they had been in 1942 and even in early 1943. At the same time, the production of merchant shipping and other wartime goods for the Allies was only getting faster. Attacks on convoys didn't go completely away until the end of the war, but at this time it was clear that the tide was now turning. So by 1944, the case for a really big cargo aircraft that could fly over the ocean just wasn't as compelling as it had been just a year and a half earlier, especially since that development program now faced more and more daunting delays. And yet, Howard Hughes didn't give up on the project, nor did he rush to get it finished. Soon the war ended, and many military contracts for other aircraft were cancelled, but Hughes kept up this work on a project which certainly looked impressive, but just made less and less sense as the time went by. Even if we ignore the fact that the U-boat threat had been almost solved in more conventional ways, the design of the Spruce Goose also had other problems. Like I said earlier, its laminate wood construction meant that it didn't need valuable aluminium, but it still needed 8 very valuable radial engines, which came with their own development problems and delays. That laminate wood construction also proved harder than expected to productionize, especially for an aircraft this big. But perhaps the most serious problem with the material was that after the war, when there was no more scarcity for aluminium and when pressurized aircraft became the future, the technology around laminate wood production just wasn't especially useful. Boeing and Douglas, who had built large bombers and transport planes during the war, were able to build on this experience to develop jetliners and other civil and military aircraft in the 1950s and 60s. Hughes couldn't really do the same with their expertise in laminate wood manufacturing, but what about the fact that the Spruce Goose was a flying boat design? Could the ability to operate away from airfields still give such an aircraft a useful role? Well, the easy answer to that one is no. While there still are some flying boats operating today, for example in firefighting or maritime patrol roles, large passenger and cargo flying boats didn't have much luck after the war. The reality was that World War II showed everyone how valuable aircraft would be in the future, and that quickly led to the creation of airports basically everywhere, not to mention the runways that had already been created during the war. So with that valuable infrastructure now coming into place, why would airlines continue to use flying boats, especially when you consider the limitations of operating aircraft this way, like the need to look out for corrosion from salt water, rough seas, or the extreme compromise in aerodynamics that came from using a hull. To be fair, Howard Hughes didn't necessarily know how aviation would evolve in the future, although, as I said earlier, already back in 1939 he did have a big hand in the development of the Lockheed Constellation, which would have a pretty healthy career as a land-based airliner after the war. As for the Spruce Goose, after even more delays, it was finally finished in 1947 and was then taken to Long Beach, California and reassembled to start making low-speed and high-speed taxi tests. Legend has it that when Howard Hughes himself set up the controls of the Spruce Goose in November of that year for yet another set of taxi trials, many of the people on board had no idea that he intended to actually take the aircraft into the air. Today, flight testing of a brand new aircraft type is only allowed with a specially trained crew, plenty of detailed briefings about every aspect of that testing, and of course nobody is allowed on board unless they are necessary for the test. But that's not how things were done back then. The Spruce Goose's first flight included 2 pilots, one of whom was Hughes of course, 2 flight engineers, 18 other crew members and 14 press people and industry representatives. Quite a crowd, but it was a big aircraft, I guess. Hughes took the plane into the air for less than half a minute, climbing no higher than 70 feet over the water, or just 25 feet according to other sources, and the aircraft then covered about half a mile before touching down again. Sadly, this would be the only flight that this impressive aircraft would ever perform. Now, there were some other controversies here as well, specifically about this flight and the real reasons behind it. You see, when Hughes did this, he was under huge pressure for his company's use of government funds to finish an aircraft that didn't seem to have any meaningful purpose anymore. And the theory was that by flying the aircraft, Hughes would prove that it was airworthy and not get in trouble for using these funds.
I've put the sweat of my life into this thing. I have my reputation rolled up in it. And I have stated several times that if it's a failure, I'll probably leave this country and never come back, and I mean it.
The aircraft had cost $23 million to build in the 1940s, which today will be around $280 million. But to be honest, I don't think Hughes made this flight just for the money. The flight itself didn't really prove any of the aircraft's promised characteristics for speed, load capacity, range or cruise altitude, since at only 25 or even 70 feet over the water, it was well within the ground effect conditions for its entire flight. And Hughes didn't just use this monster of an aircraft as a way to get government funding. We know that because even after this flight, he kept a large maintenance crew on hand to keep the Spruce Goose in good working order until his death 3 decades later in 1976. It goes without saying that any thoughts that a wooden flying boat of that size could have some practical role was completely partial by the 1970s. But all this time, the aircraft was kept in a football pitch-sized climate-controlled hangar, which was in itself amazing, and that alone showed what kind of obsession this aircraft at that point had become for Hughes. The Spruce Goose remained there in pristine condition, but away from the public until about 1980. It then changed hands a couple of times, and today you can still admire it if you travel to the Evergreen Aviation and Space Museum in Oregon. And by the way that aircraft was then broken down, carried to Oregon and then rebuilt in that museum is actually a fantastic story in itself. Even after the Stratolaunch Rocks flight, the Spruce Goose remains the largest wooden aircraft, the largest seaplane and the largest propeller-driven aircraft ever built. Howard Hughes remained eccentric and controversial until the end of his life, as has been shown in many movies and books by now, and the Hughes Aircraft Company continued to make equipment for the aircraft and spacecraft for many decades until it eventually became part of Raytheon. By the way, Howard Hughes hated the name Spruce Goose, which to be fair wasn't just unflattering, it was also inaccurate. You see, the wood used in the plane's construction was primarily birch, not spruce, so Hughes preferred to call it the Hercules instead. Still, Spruce Goose has stuck to this day. That's even what the Evergreen Aviation Museum calls it on their website. The plane has also been called the Flying Lumberyard or some other less politically correct names. Now, it is perhaps fitting that the only aircraft ever made with an even bigger wingspan than the Spruce Goose is also a one-off and the brainchild of another aviation visionary, the Microsoft co-founder Paul Allen. But fortunately, the Stratolaunch Rock has flown more than once and looks set to be used as a test bed for launching hypersonic vehicles. And if you guys know someone out there who can give me a ride on that thing, just send me an email. There are more stories around the Spruce Goose that are also worth exploring, like the fact that many of the workers that built and developed the wood composite technologies for it were women, and who also kept maintaining it and had a key role in maintaining it for the decades that followed. The Super Guppy is one of the most fascinating and wonderfully weird aircraft ever built, and the story of it comes with loads and loads of surprises. Did you know, for example, that Airbus kind of made two of them using Boeing parts? So, would it be fair to say that Airbus has actually made two Boeings? Stay tuned. I'm sure many of you know that today Airbus has a fleet of aircraft called Belugas, who they use to ferry aircraft parts around to many of their production sites. But before these Belugas, Airbus had a fleet of 4 other aircraft called the Super Guppies. Now, contrary to popular belief, these Airbus Super Guppies did not date back to the 1960s, they were actually a bit newer than that. But to understand how they came to be, and believe me, this is a truly fascinating story, we have to go back even further to the 1940s and 50s and to the incredibly fast development pace of aviation going on after the Second World War. The origins of the Super Guppy takes us all the way back to the Boeing 377 Stratocruiser. Now, in a recent video that I did, we looked at Lockheed's wonderful Constellation and how the Second World War delayed the Connie's introduction into service. But like I explained in that video, the Connie was still the world's fastest airliner when the war ended. Now, of course, Lockheed's competition wasn't really happy with that, and they weren't sitting still either. Boeing quickly put their wartime aircraft building experience to good use by designing a passenger-carrying version of their most modern large wartime aircraft, the B-29 bomber. But turning that bomber into a passenger airliner wasn't exactly straightforward. In the B-29, only the cockpit and the tail gunner position were pressurized with a really narrow tube connecting the two together, and obviously that wouldn't work really well for a passenger aircraft. So Boeing's new airliner, the 377 Stratocruiser, and the military cargo version, the C-97 Stratofreighter, basically ended up using the wing of the B-29, fitted with more powerful radial engines and an almost completely new fuselage. The lower half or lower lobe of the 377 Stratocruiser basically retained the profile of the B-29 fuselage, but the upper lobe was completely new and was constructed as the main passenger cabin. This meant that it was technically a double-decker like the Airbus A380. In theory, the 377 Stratocruiser could seat 114 people spread between the two decks, but in practice it flew with much fewer passengers than that, sometimes even configured with full beds. It really was a different time. And speaking of time, unfortunately timing wasn't on the Stratocruiser's side. The plane might have had some advantages over the older Lockheed Constellation, but it had the same fundamental problem, the looming jet age.
The jet age is now here.
The first Stratocruiser flew back in 1947 and entered service in 1949, but by then the Havilland had already flown its Comet, and Boeing knew that sooner or later they would have to follow suit. Already in 1950, Boeing was actually talking to the airlines and the Air Force about making a jet to replace the 377 Stratocruiser and the military C-97. This is probably why Boeing in the end made only 57 Stratocruisers for commercial use. This meant that Boeing lost about $7 million on the Stratocruiser program, which would be around $89 million in today's dollars. And the few Stratocruisers who did operate weren't really economically viable either, with some airlines reporting being unable to operate them profitably even with the high ticket prices of that era. Fortunately for Boeing though, the military version did much better, with 888 units built, the vast majority of which were the KC-97 in-flight refueling version. But then came Boeing's Dash 80, the 707 prototype, which first flew in 1954. The first 707 then entered service in 1958 with Pan Am, and the first military versions, the KC-135, started refueling military planes even a year before that. All this meant that despite its luxurious cabin, which made it a desirable airliner to fly inside, the Stratocruisers simply had no chance of surviving as a passenger aircraft. Its poor economics meant that Lockheed's Constellation, the plane it was constructed to replace, actually ended up outlasting it. Pan Am retired the last 377 Stratocruiser back in 1961, and they were the last airline to fly them commercially. The military versions ended up lasting a little bit longer, mainly in reserve roles. But this sad ending of the Stratocruiser's career in passenger service was actually the beginning of the Guppy, thanks to some real insightful out-of-the-box thinking. The origins of the Guppy started with a man called John Michael Conroy, whose life is actually a great story in its own. He was better known as Jack Conroy, and he started off working as an actor prior to World War II. He then moved to Hawaii, where he got bombed at Pearl Harbor while working as a civilian on underground fuel tanks. After that, he joined the US Army Air Force and became a B-17 pilot, flying in combat all over Europe before getting shot down and eventually captured. All of this happened before his 24th birthday. Conroy survived the captivity and stayed in the military after the war, flying fighters like the F-86 Sabre for the National Guard. But besides his military piloting career, it seems like Conroy also had a keen business sense, always looking out for an opportunity. And what was happening with Boeing's 377 Stratocruiser looked to Conroy exactly like such an opportunity. Starting in the 1960s, just as the 707 and the KC-135 started to replace the 377, dozens of those aircraft were going into storage or on sale for ludicrously low prices. And remember, most of them were barely a decade old at that point, and they were still technically sound aircraft with relatively few hours on their wings. Again, it wasn't just the arrival of the jet age that had made them obsolete. The 377's relatively low passenger capacity for its size had also made it difficult to operate profitably as a passenger airliner. So what if there were some other role it could be used for? That's exactly what Jack Conroy and some of his friends thought as well. So they ended up actually buying several surplus Stratocruisers even before they had any real plans for how to use them. And sure enough, something else was indeed about to happen, which would soon grab Conroy's attention, and that was space.
The space age has begun, and America appears to be losing.
As I'm sure most of you know, the launch of the Sputnik satellite by the USSR initiated what's now known as the space race, which would eventually end up with the United States putting the first man on the moon. Sputnik flew in 1957, and NASA came into being just a few months later in 1958. But the thing was, NASA quickly found itself dealing with some pretty serious logistical issues involving some geographical bad luck. The agency needed its spacecraft to launch on an easterly heading in order to reach orbit, and they didn't want the rockets to overfly inhabited areas. So they picked Cape Canaveral in Florida as the launch location for their moon missions. But a lot of the companies making rocket sections and other components for the Saturn V rocket were located in the west coast of the United States, meaning literally on the other side of the country. Now initially, smaller components could be carried through the country using existing infrastructure, but as time went on, NASA's space vehicles just kept getting bigger and bigger, and to get the largest components of the Saturn V monster rocket from California to the East Coast, NASA started using barges. So believe it or not, before that giant space rocket could break the sound barrier on its way out of space, big parts of it had to be loaded onto a big barge, then float slowly south all the way down and through the Panama Canal, and then make its way back up north along the Gulf of Mexico. It wasn't long before Jack Conroy and his friends realized that their stored Stratocruisers could help NASA solve this logistical nightmare. But when they first approached NASA about it, they were cold-shouldered. A NASA official even told Conroy's team that the contraption that they were working on barely even looked flyable. It looked like a pregnant guppy. But this didn't deter Jack Conroy. He put every last penny he had into the company, which he called the Aerospace Line International. And he made the first plane, which he actually named the Pregnant Guppy. That first aircraft was a Boeing 777 Stratocruiser, which had first flown for Pan Am. And to make the Pregnant Guppy, the aircraft first had to be lengthened with an extra section from another 777, which had flown from BUAC, the precursor to British Airways. The biggest change then involved the upper half of the fuselage, which now got a diameter of 6 meters. Initially, this new structure was simply added to the existing fuselage underneath to test the whole thing aerodynamically. That first test flight took place on the 19th of September 1962 with Jack Conroy himself at the controls along with test pilot Clay Lacy. Legend has it that when the tower controllers realized that Conroy actually intended to fly the thing, they alerted the local police and the fire departments. But it turned out that the aircraft actually flew more or less like a normal Boeing 777 Stratocruiser, although the extra drag unsurprisingly kept the speed a bit lower. The next step was to complete the transformation by removing the existing upper fuselage, but Jack Conroy and his company unfortunately ran out of money before they had a chance to start doing that. Conroy had to actually borrow more money just to pay for the fuel so he could fly the half-finished aircraft from California down to the Marshall Space Flight Center in Huntsville, Alabama. He did that to demonstrate it to NASA officials because he now desperately needed the contract in order to be able to continue to develop it. It was there that the Pregnant Guppy got a very important supporter in the director of the Marshall Space Flight Center, Wernher von Braun. More test flights were then made, demonstrating that the aircraft would be safe even in the event of engine failures. Conroy's money gamble paid off, and the completed plane eventually ended up flying NASA cargo less than a year after that first test flight. But the Pregnant Guppy was just the beginning. NASA soon had a second Aerospace Line International aircraft to its disposal, called the Super Guppy. This one was a bit larger, with an inside diameter of 7.6 meters. This made the Super Guppy wide and long enough to carry the S-4B stage of the Saturn V, basically the third stage of the rocket. This new aircraft also was equipped with 4 Pratt & Whitney T-34 turboprops instead of the 377 radial engines, which was needed in order to make it be able to carry more weight than its predecessor. The original Pregnant Guppy didn't have a proper door to its massive cargo bay. Instead, it was designed in a way so it could basically be broken in half behind the wing, loaded up, then literally bolted back together again for the flight. But that meant, of course, that it also needed to be disassembled again for unloading every single time. The newer Super Guppy was a little bit more refined than that. It had a door hinge in front of the wing, which was used to open it up, but it still presented some practical problems for the crew who was flying it. Because neither of the aircraft had pressurization, so they had to fly low and therefore constantly watch out for bad weather. And just as importantly, since the cockpit was part of the door, the plane's flight controls had to be disconnected and reconnected every time the door opened. Remember, this was way before fly-by-wire was a thing. This obviously added a lot of extra flight control checks that the flight and ground crews had to perform before every flight, but it was all worth it. NASA saved a full 3 weeks per journey by using these guppies instead of putting the rocket stages on a barge. And this was obviously a huge deal given how fast the space program had to evolve. Wernher von Braun later would state that the Guppy was the single most important piece of equipment to put a man on the moon in the decade of the 1960s. But what about after the 1960s? Well, years before Neil Armstrong and Buzz Aldrin put their feet on the moon, Jack Conroy was already thinking about what would come next. Because for all of their awesomeness, the Pregnant Guppy and the first Super Guppy had a rather serious problem. They were not certified. To accomplish their role in sending people to the moon, these planes had been declared public aircraft, not subject to FAA regulations. This is something normally done only for military, government, or some experimental aircraft in very special cases. But obviously, if Jack Conroy and his company wanted to hire out these planes as freighters and to other customers than NASA, they would need to be properly certified, and this is why the company continued to refine the design. The next version was probably the least well-known of them all, called the Mini Guppy. Now, there wasn't anything mini about it other than the fact that it had a cargo bay with a slightly smaller diameter, and if you're a fan of all the Jean-Claude Van Damme movies, you might remember this plane from the opening scene of the Universal Soldier. This aircraft also introduced a number of innovations in the Guppy family. Firstly, it had a new fuselage, which eliminated the double bubble look of the earlier Guppies, where you could see a line between the original lower fuselage and the new inflated upper fuselage. This allowed the floor of the cargo area to get bigger, 13 feet or 4 meters wide instead of 8 feet or 2.4 meters in the previous Guppies. The new fuselage still incorporated original fuselage sections, including the empennage and of course the cockpit, and for the first time in a Guppy, the cockpit was now pressurized. That first Mini Guppy still used the original radial engines of the Boeing 377, but a newer version was equipped with turboprops, this time the Allison 501 Delta, versions of which was powering the C-130 Hercules and the P-3 Orion. This turboprop version was called the Mini Guppy Turbine, but sadly it crashed during testing. Aerospace Lines International then used the modifications it had developed for the Mini Guppy, like the new wide floor fuselage and the installation of the Allison turboprops, to come up with the Super Guppy turbine. The first Super Guppy turbine didn't fly until August 1970, and by the time it got its certification, the Apollo space program was already winding down. And despite their forethought about a future after NASA, Aerospace Lines found themselves in financial trouble. That's why the company decided to look for a buyer for its first Super Guppy turbine, instead of operating itself as it had done up until that point. And this is where Airbus finally comes into the picture. As you probably know, Airbus assembles their aircraft at different sites around Europe and now even outside of Europe. But even in the very beginning, when Airbus developed their first jet, the widebody A300, they needed something that could carry bulky aircraft parts between their production and assembly sites in Spain, France, Britain and Netherlands and Germany. Soon, Airbus agreed to buy the first Super Guppy turbine, and in 1973 they took up an option for a second aircraft. Remember, Airbus was a relatively new company back then. It was founded in 1970, and as they grew, their need for Guppies also grew. So by 1978, Airbus had decided that they needed 2 more Super Guppies. At that time, the company was still working with Aerospace Lines, mainly for the maintenance of the old planes, but by then it was decided that if Airbus wanted more Guppies, they would need to make them themselves. Well, sort of. Aerospace Lines still owned the type certificate of the Super Guppy turbine, and they ended up supplying the major sub-assemblies that Airbus would need to put the third and the fourth plane together in Toulouse in France. Officially, Airbus subcontracted this work to Union de Transporteurs Aériens, or UTA, which was actually a French airline with a sizable maintenance, repair and overhaul center.
UTA Industries, a division of UTA French Airlines, also services and maintains some of the world's most sophisticated and unusual aircraft, like the plane behind me, a Super Guppy. You've heard the story of Jonah and the whale? Well, this is the whale, and it flies.
UTA has since been absorbed by Air France, by the way. So, to answer the question in the beginning of the video, did Airbus actually build 2 Boeing aircraft? Well, no, they didn't really. But these planes actually had Boeing 377 nose sections, including the cockpit, Boeing 377 wings and Boeing 377 empennage or tail sections. The main landing gear also came from the 377, but curiously the nose gear came from another Boeing, the 707. Airbus used these wonderful planes for nearly 2 decades before replacing them with the newer A300-600 ST, the Super Transporter. Of course, nobody actually calls these planes that. We all know them as the Belugas. On the Beluga, you can see how Airbus ensured that the cockpit wasn't part of the door, so they wouldn't need to disconnect and reconnect and recheck all of the flight controls every time that the door opened, likely a lesson that they learned from the Guppies. And recently, Airbus has actually started to replace the Beluga fleet with the even larger Beluga XL, which is based on the A330. Thankfully, 3 of the 4 original Super Guppy turbines have all been preserved in museums, and even better, the 4th one is still flying. Airbus part exchanged that aircraft to NASA on behalf of the European Space Agency, and NASA is still using it to carry bulky loads. It was actually used to carry some of the components for the International Space Station. By the way, the aircraft that NASA is now using is the fourth and newest Super Guppy turbine, which means that it was made in France, meaning that it never flew any parts of the Apollo program. Or did it? Well, this plane actually incorporates the empennage section of the even older pregnant Guppy. And that's because back in 1979, when the Aerospace line was making the sub-assemblies for this plane, there weren't any spare Boeing 377 tail sections to salvage anymore. So what they did was they recycled this section from the older pregnant Guppy, which by then was retired, and that means that part of this plane, which is still working for NASA today, actually did fly parts of the original Apollo program. That's so cool. These are all fantastic aircraft, and I have to give a big shout out to the All About Guppys website, which is a fantastic online resource containing even the most impossibly nerdy details about these unique planes. You should definitely check it out. Finally, I think that if any aircraft exemplifies the phrase, "If there's a will, there's a way," it is definitely the Guppy. Now, I really hope that you liked this story, and if you did, please leave a like and a comment and even share it with a friend, and of course, subscribe to the channel. If you want to support our work here on the channel, we're actually 6 people working on it, well then consider becoming part of my awesome Patreon crew, which will give you access to previews, hangouts and much more. Now, check out these videos next. We're really proud of those, and buy yourself a t-shirt if you want to support. Have an absolutely fantastic day, and I'll see you next time. Bye bye.